So the purpose of this example is to kind of bring all this together for mate 7 and show you where the three important parts of the graph will occur. And actually, a fourth part will come out of this as well. We've learned throughout the year that the graphs of these equations have specific features to them, like the y-intercept and the slope of a line, like the vertex and the line of symmetry and the x-intercepts of a parabola, the launch point or the vertex of a radical function. We have all these key points that occur. Well, rational graphs, the graph of a rational function, will have these three key points: poles, asymptotes, x-intercepts. All right? In order to see whether it has any of those, the first thing that you want to do is factor. Factor the top and factor the bottom, and tell me what you get. The numerator is x plus 2 times x plus 6. Could you reverse the order there if you wanted? Sure. Denominator, x plus 2 times x plus 3. So will this function have all three features? In the example up here in red, green, and blue? Yes. What is most like red? Or what matches the red? Where will the hole be? At -2 because of the fact that the x plus 2's cancel. So we know that there will be a hole in the graph when x is -2. Is there a factor in the bottom that doesn't cancel with one on top? And that's blue, right? Like the x minus r2 up here. What will this produce? A vertical asymptote at -3. Holes are produced when the factors do cancel. Asymptotes are produced when the factor doesn't cancel. We called the holes in the graph removable because we were removing them. Okay? We called the asymptotes non-removable discontinuities because you could not remove them. You could not cancel them. Now, is there an x-intercept? Yes. For the x-intercept, you want to look at the numerator. What would you plug in to produce 0 up there? So there's an x-intercept at -6. So if you were going to make a graph of this, one thing you could do is you could go left 6, and you could put an x-intercept. You could go to -3 and draw, what's this? A vertical asymptote. And when x is -2, you would have a hole in the graph. Where would you find the hole? -2, comma, question mark. So there's like a follow-up. Where do you find the hole in the graph? The hole will be at -2, comma, do you remember this guy? Plug -2 into the stunt double. In other words, what do you get when you plug -2 into the remaining uncanceled stuff? Does that make sense? The stuff that doesn't cancel. What do you get when you put -2 in? -2 plus 6 is what? 4. On the bottom, -2 plus 3. 1. What's 4 over 1? 4. So that's where the hole would be, at -2, comma, 4. Now there's one other thing for us to find. Actually, two things. Horizontal asymptotes go by this chart on the left side of the whiteboard. For those of you watching the video, it's the part that talks about if it's top heavy, there's no horizontal asymptote. If it's bottom heavy, y equals 0 is the asymptote. If it's balanced, then you look at the ratio of the front coefficients. In the front, what's the coefficient in front of x squared? In front of x squared, what's 1 over 1? Y equals 1 is where the horizontal asymptote would be. If you can find it, find the y-intercept by plugging 0 in for x. Are we allowed to plug 0 in? What do you get when you do 0 plus 6 over 0 plus 3? 2. So that's where your y-intercept is. So this graph is going to look something like this. And there would be a hole at -2, 4. Sorry, that shouldn't have been, it should be open circle. -2, 4 is an open circle. So those are the basic features of rational functions. You have to find vertical asymptotes, holes, x-intercepts, y-intercepts, and horizontal asymptotes. Another discussion we're going to have later in this period is slant asymptotes. What happens when it's top-heavy?